Hello, everyone. I'm Steve Lowry, the Executive Director of AI in BC. And I'd like to welcome everyone to everyone in the mining community, as well as the AI community, for what promises to be a really interesting discussion on where these two worlds collide. I'll start today by acknowledging that we're gathered for this event on the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. As a quick note, as I said, please keep your mute on and your video off if you could, if you're in the audience. Appreciate that. And then, so for those of you who don't know a lot about AI in BC, I can bring you up to speed by saying that we are the industry body for artificial intelligence in British Columbia. We work closely with over 200 companies commercializing AI to grow the province's economy through technology initiatives. We also advise the provincial government on how best to invest in this space. And we work with research universities of BC to help move the best research innovations into the commercial realm. Now, a recent example, actually, where all these activities have come together is in a project started by one of AINBC's board members, Alan Mackworth, to bring together a network of researchers throughout the province with startups and enterprise to focus on AI commercialization and new technologies. We're calling this the Horizon Initiative, and we've been working closely with UBC and SFU in this past year, also the Digital Supercluster, who's really helped us to accelerate this as we start building this project together. So stay tuned for more news on that. But it's our goal as AINBC to kind of be at the nexus point of these different communities, and certainly other industries like mining and others, which are often very topical as it is today. For today's event, we really thought it was a good time for to focus on mining and how AI relates to it, because times are changing. Mining has been a big part of BC's proud business history, and looking ahead, I think the most successful miners and mining supply companies are going to be leveraging digital technologies to the fullest. So it's sort of high time for this discussion in the community. I'm really looking forward to it. Don't want to steal the thunder of our moderator, though, on this topic. So let me introduce him now. KPMG is the presenting sponsor for the event today, and AINBC has a fantastic working relationship with KPMG. We partner with them on thought leadership events and a large capacity building consortium we have to train 500 women in AI. That's called Athena Pathways. So always like working with KPMG. And our moderator today is Jamil Ahmed. He's a partner at KPMG's digital strategy and transformation practice within the consulting function based in Vancouver. With progressive experience in industry and Big Four consulting in Canada and the United States, Jamil has built a wealth of experience assisting organizations in delivering sustainable digital and technology strategies by bringing enterprise in information management, advanced analytics, and disruptive emerging technologies. Jamil sits on KPMG's Canada Digital Leadership Team and also serves as a board advisor to AINBC. So I will turn it over now to Jamil.
He's trying to log in again. He sent a note that he was having.
Got dropped off. Okay. Well, we can.
I'm back. Can you hear me now?
Yeah.
Yes, we can.
Oh, perfect. I think when you mute the participants, it blocks us from unmuting ourselves.
Okay.
So I'll just turn on the video. Can you see me?
Yes, perfect.
All right. So there we go. So much for Zoom 101 there. But pleasure. Thank you, Steve, for that introduction and the great work that AINBC is leading for BC and our AI ecosystem. Very excited. Thank you for the audience today. Very exciting topic. We have some great speakers lined up, and very important topic near and dear to my heart and the hearts of many at KPMG. And we're really looking forward to this session. So it is with great pleasure that I moderate the session today. And so just by way of intro, I'm a partner in KPMG's digital transformation and strategy practice, and I serve on the board of advisors for AINBC. As I said earlier, KPMG's proud for this event where we have the opportunity to hear from our BC mining leaders. They're working hard to transform the innovation capabilities in the mining sector. Over the past few months, we've seen that as we've responded to the global pandemic, it has forever changed how organizations are going to be accelerating their digital transformation efforts. And it's important that we underscore the support of these organizations, but also of executives working within these organizations to strategically adopt AI in order to essentially set us up for the future. And making sure that both from an economic and a social perspective, that we are taking a longer term mindset into the equation. So artificial intelligence, as we define it, it should no longer be imagined as high-tech experiments that are peripheral. In fact, AI in its various forms is pertinent to every aspect of our lives. It is fundamental to adopt into the new business models, to respond to talent shortages, and to create efficiencies in what will become an ever increasing competitive global environment, and a global race to meet societal needs. So maintaining status quo is a risky business proposition when our competitors globally are deploying AI technologies at tremendous speed and impact. So, British Columbia is ripe for investment in adoption of AI. Our AI ecosystem has a flourishing ecosystem of over 150 AI companies, which has produced some globally recognized unicorns over the years. British Columbia's businesses are poised to take advantage of the tremendous talent pool which is developing in our region. In the recent work that the Mining Association of BC completed in a report called The Innovation Advantage, I quote, "BC is well positioned as a world leader in sustainable mining, as greater emphasis is placed on climate change, a low carbon footprint, and responsible mining operations. BC Metals and Minerals can be a global brand of choice, providing ongoing employment and benefits across the province for years to come. We are a leading supplier of low carbon metals and minerals that are essential for clean energy, renewable energy, infrastructure, and consumer technologies. We meet the highest standards of environmental, social, and governance performance. For example, our sector is a leader in advancing economic reconciliation with BC's Indigenous peoples and works within a strong regulatory framework," end quote. Business leaders in BC, including board level directors, senior management, and private company owners, have a responsibility to be at the forefront of AI adoption to enable the demand side. This involves reevaluating your business model and perhaps coming up with a new one that can sustain ongoing innovation, leveraging available data and developing new performance structures to foster AI in mining and innovation. As I wrote these opening remarks, we just heard of another global brand that has just announced a strategic technology-related investment in BC. We're seeing the frequency of the press releases by these globally recognized names as a signal that we're moving from experimental to applied AI and entering a new wave of innovation, powered by AI and sharing of data and insights across the sector. Data availability and usage will be an imperative, with government facilitating data sharing across the sector as has been done in other global jurisdictions. This will be the key to building a data-driven mining sector, which is trusted. We continue to witness the growing desire to support the development of our ecosystem, to strengthen our innovation capabilities, and to address our core industry needs. We're seeing increasing support from the provincial and federal governments, hard work of organizations such as AI in BC, working closely with the Digital Technology Supercluster and the academic sector on initiatives such as the Horizon Initiative. We have witnessed BC Tech Association's efforts on promoting the BC Tech ecosystem to support the startup and the growth of the technology organizations in our region. And we're witnessing a shift as a region's identity as a major global player in the tech sector. In fact, one of MABC's key recommendations is to create a BC Mining Innovation Hub to foster a cooperative mining innovation ecosystem to address the sector's emerging challenges. So with that, from a KPMG perspective, we've been part of the fabric of BC business for the past 120 years. As we innovate how we deliver our services to our clients, we will continue to invest in the strategic imperatives for BC. Our innovation center, dubbed the Ignition Center, continues to bring together local and global experts with experience implementing AI in practice and driving an innovation culture within these organizations. Mining is a critical sector for BC's future, always has been and will continue to be. And it is important that we take a global leadership position with respect to mining and innovation. So with that, thank you again for the opportunity to moderate today's session. And I take great pleasure in inviting Michael Goehring, President and CEO of the Mining Association of BC. In this role, Michael brings BC's mining sector vision, passion, and decades of experience providing public affairs and strategic communications counsel to leading natural resource companies in BC and Canada. He joined the association following a successful career as a partner in the Vancouver office of Canada's largest communications firm, where he built a strong reputation advancing challenging public policy files and delivering successful advocacy and communications campaigns. Welcome, Michael, and over to you.
Thank you, Jamil. Could I just check and make sure that you can hear me clearly? Coming in loud and clear?
Yes.
Okay, super. Thanks very much, and good afternoon, everybody. I'm pleased to be joining you from the unceded territory of the Coast Salish people, and I'm pleased to be kicking off this online event, AI in the Mining Value Chain. My name is Michael Goehring. I'm President and CEO of the Mining Association of BC. I think it's worth mentioning to start that at MABC, we just celebrated Mining Month this past May, along with our 120th anniversary as a trade association. Importantly, the theme of Mining Month was innovation, which built on the work we did in 2020 to develop our mining innovation roadmap, which Jamil mentioned. That recognized the innovative spirit of the mining sector, which has been constantly embracing and implementing new technologies and solutions, which is relevant to our discussion here today. I've been asked to touch on a number of things. I'll touch on the importance of our industry to British Columbia, in fact, to our entire nation from coast to coast to coast, and then talk about innovation and our innovation roadmap. BC is a world-class mining center. Every community in the province is a mining community. If you haven't had the opportunity to review our report, One Province, One Economy, I would urge you to do so if you have interest in our sector. You can find that on our website, and I would encourage you to have a look. It's a quick read. Prior to the pandemic, BC mining represented 25% of our province's exports, generated some 12.3 billion in revenue, and supported 35,000 direct and indirect jobs in communities across BC. We also contributed more than $1 billion in direct payments to government to support public services that British Columbians rely on. Our industry has a vast BC-based supply chain, and within that, there's more than 3,700 suppliers that benefit from working and providing goods and services to the mining sector in every region of the province, to the tune of almost $3 billion in sales annually. And to that point, every community is a mining community. More than 1,250 mine suppliers call the Lower Mainland home, and they provide almost $1 billion worth of materials, goods, and services to the mining industry on an annual basis. And here in Vancouver, which we refer to as BC's largest urban mining community, there are more than 485 mining suppliers who generate some $250 million annually doing business with BC's mines and smelters. Mining is foundational to our provincial economy, and there is a bright future for our sector. It is not a sunset sector. We have the opportunity in BC to be a brand of choice in supplying the minerals and metals the world needs to transition to a clean, low-carbon future. And in fact, the World Bank in 2020 underscored how the large-scale transition to cleaner energy will drive significant demand for the minerals and metals produced in BC: aluminum, copper, gold, zinc, molybdenum, and metallurgical coal. These are all used to build clean technologies and infrastructure to reduce greenhouse gases, not to mention the role they also play in building smartphones and many of the products we use every single day in our lives. At the same time, the world, governments, investors, companies, and the public are placing a higher importance on environmental, social, and governance performance, or ESG. In BC, we have a real ESG advantage. And many of our members, one being Teck Resources, have been working towards higher ESG performance before ESG was part of the nomenclature. Back then it was corporate and social responsibility or sustainability. Thanks to our clean electricity and advanced mining and refining methods, we have some of the lowest GHG emitting mines and smelters in the world in BC. We also meet some of the toughest environmental health, safety, and social performance standards. And as global expectations continue to evolve, demand will increase for products from responsible sources, and BC is well positioned to meet this demand. And that opportunity is very real. There are new mines and mine extensions right now on the drawing board that are well along in their development that can capitalize on a global economic recovery that is much stronger than we expected. Today, there's 7 projects that could be significant contributors to our economy, delivering more than $4 billion in investment, 2,000 construction jobs, and more than 4,000 new operating jobs. These new mines and mine expansions can accelerate our economic recovery at a time when British Columbians need it most. One example is Artemis Gold's proposed Blackwater mine near Vanderhoof. If approved, this new mine could boost the economy of the central interior, creating more than 800 construction jobs and more than 450 new operating jobs at a time when the region is coping with mill closures. And importantly, our mines are also advancing economic reconciliation with with Indigenous peoples in BC. Blackwater, the Lacuse Dene, and Alcacho Indigenous nations have already signed participation in resource revenue sharing agreements with Artemis. So in BC, we're well positioned to take advantage of the changing demands and expectations of the market, but we have work to do. And that's why MABC partnered with the provincial government to develop the BC Mining Innovation Roadmap. The roadmap outlines our industry's path to boost competitiveness, improve our sustainability, and build resilience through innovation. Now, innovation has been a constant presence in British Columbia's mining industry. Our members have a long history of adopting innovative mining methods and creating new technologies that are now today used the world over. Innovation and the adoption of advanced technologies are increasingly necessary for our members to remain competitive, to improve our environmental, social, and governance performance, and succeed in a rapidly evolving and increasingly competitive world. Today, our industry continues to embrace industrial advances in science and engineering, including the application of state-of-the-art solutions like AI, machine learning, big data, 3D technologies, and electrification. For now, for example, we use sensors to tell the difference between waste rock and economic ore. And Martin Heist from MineSense can certainly speak to this better than I, and I believe he will do so later in the program. Really, innovation, it's really about developing new technologies and approaches that will minimize environmental impacts, enhance operational competitiveness, and create more sustainable value for all involved. Some examples of this could include Pretium Brucejack mine, their conversion of their diesel haul truck fleet to battery electric vehicles, or Teck Resources' innovative application of antimicrobial copper on high-touch surfaces. So with the Innovation Roadmap, we launched it with Minister Ralston in March, and you can find a copy of that on our website at mining.bc.ca/innovation. The roadmap doesn't purport to have all the solutions. It is, as the name states, a roadmap. It serves as a guiding document for policymakers, industry, and everyone in the mining value chain. It was developed through significant consultation with Indigenous people, industry, labor, communities, the tech and clean tech sectors, academia, and other stakeholders. It's a solid document, and we're pleased with the final result. In part, that's because of the meaningful buy-in of all of our partners. We had nearly 300 people participate in the development of the roadmap, including people from the AI community. Collectively, representatives introduced more than 150 ideas or suggestions during 8 workshops and 5 special engagement sessions. And no surprise, when you bring together a lot of mining people, engineers, etc., there's going to be a significant number of opinions, perspectives, and visions about what can be done better. So the roadmap lays out a strong foundation, thanks in large part to who participated and what they represent within the industry's ecosystem. So a few words on that. Just to be honest, and here's humor, it wasn't until the advent of the roadmap that I actually knew a mining ecosystem existed. But what I do know is innovation thrives with collaboration. And in the context of the roadmap, the ecosystem includes all of the organizations that have a role in the development and implementation of innovation in BC's mining sector. That includes the industry, those in exploration, mining suppliers, equipment and tech providers, funders, supporters, communities and customers, importantly, education, R&D, and tech companies at the TRL tech readiness level of less than 5, and R&D and commercialization projects at the TRL 6 and up. And so as I look out, I think there's about 45 people on here. With the power that's vested in me, I now make you all honorary members of the BC mining ecosystem. So welcome. Between many of these organizations and individuals, there are existing relationships, but there's a real opportunity and frankly a need to strengthen the connections. This is going to be a core function of one of the central recommendations of the roadmap, which is to establish the BC Mining Innovation Hub. The hub is the overarching recommendation stemming from the report, and it receives strong support from all the participants in the engagement process. The hub, in partnership with industry, governments, and other stakeholders, will accelerate innovations and enhance competitiveness across a range of areas, including environmental protection, clean tech, emission reduction, and the regulatory framework. I'm happy to report that the BC government heard us. The province is committed to work with MABC and fund the creation of the Innovation Hub. I'm expecting we'll continue to work with government over this next year to determine what the hub will look like and how it will function. And we'll continue to work with government to ensure that its regulatory regime is open to testing and embracing innovation of all types. This is important. The reality is that no mining company will bring forward an innovation or new solution if they know it's going to lengthen permitting timelines or worse, create uncertainty in the permitting process. So while the hub is a central recommendation, the roadmap set 4 goals supported by 18 action items. And those 4 goals include fostering an innovative and collaborative culture, improving regulation to support innovation, leveraging BC's ESG advantage, and building the workforce for the future mine. The first goal, to foster an innovative and collaborative culture, is consistent with my earlier remarks about the need for greater interaction across the ecosystem. We really need to get to the point where it's expected that our mine managers, geologists, safety leads are taking meetings with scientists at UNBC or with upstart tech companies in Gastown that have a promising idea. It's the aim of the Innovation Hub to help facilitate those interconnections. The roadmap also provides additional supports and recommendations to foster this collaborative culture. One of those key action items to highlight is the creation of an innovation mine. That idea is borrowed from Ontario, where the NORCAT Underground Centre functions essentially as a demonstration mine. NORCAT provides a place where startups and other enterprises can develop, test, and demonstrate innovative and emerging technologies in an environment that mimics an operating mine. Now, with respect to regulation, in BC, we have one of the most comprehensive regulatory regimes in the world for mining. This is a net positive for our industry and helps provide credibility on the ESG performance of our mining sector. However, at the present time, the regulatory regime is too complex and takes too much time and can be unnecessarily onerous. Perhaps most concerning, the lack of regulatory certainty is a true barrier to attracting investment to the province in spite of our world-class reserves. So let me be clear though, when I talk about improving regulations, we're talking about better process, not less environmental protection. So with respect to the second goal of the roadmap, it's really about proposing that industry and government work together to co-create what we would call a risk-based regulatory framework. So what does that actually mean? Well, what it means is there's less time required when a mine wants to use a proven technology to complete a no-risk or low-risk process, that's good for everybody. Mines don't get bogged down in unnecessary bureaucracy that does nothing to enhance the health or safety of a mine operation. And it also means that government doesn't tie up its finite resources on work that doesn't really need to be done. And as both a British Columbian and a representative of our industry, I think that's good public policy that benefits everyone, and it's something that we're very committed to. Our third goal, leveraging our ESG advantage. While BC's industry is leading in many ESG considerations today, it's something that we collectively need to be constantly improving. ESG factors are not a box that you can check off as accomplished. The goalposts for leadership are constantly changing. So there are two central tenets to achieve this goal in the roadmap. First off, we need to credibly establish BC on an ongoing basis as leaders in ESG performance. And second, we need to work with government to create a responsible metals and minerals markets development strategy to ensure that buyers are aware of what BC miners are doing, so they value and prioritize our products over those of other jurisdictions. And I'm pleased to report that work is underway on developing a responsible metals and minerals strategy beginning this month. The last goal, building the workforce for the future mine, is a challenging one, but it's no less important than any of the other goals. We need to be open and prepare for the fact that the labor needs of the mining sector are changing. And I expect we're going to see a continued and rapid evolution in the skills mines require. This isn't a challenge unique to our sector. Technology and innovation bring automation and a requirement for different skill sets. Industry, government, Indigenous nations, unions, and communities are going to need to work closely to ensure that the people who want to work in mining jobs are given the right training to benefit from long-term careers in our sector. Innovative approaches to building a workforce, whether it's attracting new skilled workers, retaining skilled workers, or reskilling existing workers, is vital. We also need to develop the workforce with an eye to greater inclusivity and diversification, which necessitates removing the barriers to underrepresented peoples within our industry. And I'm happy to say that CTEM, the Center for Training Excellence in Mining, is currently developing a mining skills roadmap, which is tackling these challenges head on. And I think is relevant to our discussion here today insofar as ensuring there is new talent that speak both languages of mining and tech. So to conclude, mining offers many opportunities for British Columbians in the months and years to come. We're excited to work with our industry partners and stakeholders to spur the province's economic recovery and to leverage our growing brand as responsible producers of the critical minerals and metals the world needs for a better low carbon future. The innovation roadmap provides a pathway for us to fulfill this potential. So that's why it's important for me to be here today participating in this event, to spread the word, make connections, and incent action across the mining ecosystem. We need a commitment and collaboration from all sides to transform the roadmap into tangible results. And that includes the AI in BC network. And with that, I'll cede my time. Thank you for your interest and attention this afternoon.
Thank you, Michael, for your and MABC's hard work to progress our goals in the mining sector. And just to repeat, it's mining.bc.ca for those who have not read the report. It is a very comprehensive report, which goes into further detail on the goals that Michael touched on, and quite a worthwhile read. So Michael, we look forward to the continued collaboration with yourself and MABC, and looking forward to progress on those goals. Thank you. With that, I will now invite Livia Meller, CEO of Computational Geosciences. Livia Meller is CEO of Computational Geosciences. Livia founded the company as well as Greenstone Venture Partners. Ms. Meller is on the board of Endeavor Mining Corporation, Computational Geosciences Inc., and High Power Exploration Inc., and member of the Institute of Corporate Directors and member Institutional Investors Committee at Canadian Venture Capital Association. Livia, thank you for spending your afternoon with us, and over to you.
Thank you very much. It's a real pleasure and an honor to be on that panel and present the view of an entrepreneur, somebody that started the company, and this is the view from the trenches. The company that startup that had to go and raise capital and generate revenues and become profitable, because if you don't do that, you don't survive for very long. While some of the themes, perhaps, you've already heard, and I will repeat at least a little bit. I think that in my presentation, I will add additional information about sort of what AI feels in terms of developing solutions and how we go about it, and fundamentally a few offerings that we have as a company. I'll try to share my screen, assuming I can do it. Here we go. So our company has been developing technology solutions for 3D subsurface imaging, as well as AI-based solutions already for a few years. If we think about mining value chain, our technology covers the resource discovery, management, all the way through operational process optimization areas. Here we go. Now I'm going to try and, here we go. In my presentation, I would like to pose a few questions and try at least to provide some answers. And the first one, of course, is I wanted to make a pitch, why BC? I read the announcement today about the Sudbury Center getting 40 million from the government for mining innovation technologies. And I thought, I wish it would be BC. But nevertheless, I will share sort of what I see, why we should have this in BC as well, and probably be bigger and better than anyone else. Would like sort of also to touch upon what we see in terms of market demands that are driving technological innovation in mining, and why it's all revving up very rapidly. As a developers of AI solutions, we know that there are specific needs that are essential for successful development and deployment. So I will talk about that. And finally, I do want to present at least 3 AI solutions that Computational Geosciences offers to our clients. So why BC? I come from a technology venture capital background, and spent many years in Silicon Valley, which of course is a mecca for technology innovation. And every time I would come back, I would say that British Columbia actually is Silicon Valley for mining technology startups. And it has all the critical success factors. We have an incredible experienced entrepreneurial base in mining. We have availability of risk capital. So in BC, people know how to take the risk and to roll the dice like nowhere else in the world. We also have a presence of large mining anchor companies, which are essential. They spin out professionals. They spin out mining engineers and exploration geologists and geophysicists and geochemists. And many of those people join startup companies and bring that necessary expertise how to grow those companies. We have a history of successes. We don't have to explain to anyone that in BC, we have a very successful track record with mining. And very importantly, we have universities and colleges that are pursuing relevant research and training programs. So overall, I say that BC contains the entire ecosystem required for technological innovation in mining. It's quite unusual because I think we are very unique in that respect. So why BC? Because we are the best here. What are the new market demands that are really revving up the technological innovation in mining? Look, this innovation has been happening for a long time, but I would say that the rate of adoption in mining has been much slower compared to other industries. Even if I look at natural resources, I would say that oil and gas, they are, in terms of adopting technologies, they are 10 to 20 years ahead of mining. And then mining is probably about 10 years ahead of water. But the new important factors, and Jamil mentioned that, and Michael, is that transition to clean energy and renewables, and critical minerals are essential to achieve those objectives. Without those minerals, there is no clean energy. Then there is this ESG, reporting and disclosure. They are happening at granular level. They have to be auditable, which means that there will be way more monitoring, whether it's tailing ponds, water quality, et cetera. They have to be automated. There will be more data, and the data will need to be collected and analyzed. So that also is driving that technological innovation faster. The demand for operational excellency has always been there, but management and shareholders are looking at increasing productivity at lower costs. And finally, the ever-increasing volumes of data require new tools to evaluate, analyze, and transform this data into actionable items. When we talk to clients, that's what they express. That's what they say. We haven't thought about doing it yet, but these are the reasons why we think we need to move forward faster. So what could be done to support that faster development and more successful deployment of AI solutions? Again, I'm looking now from the point of view of startup company trying to develop and promote AI solutions. While there is a lot of talk in mining about AI and general in natural resources, we are still at the early stages of market penetration. We have challenges. Are we okay? Is there somebody trying to say something? No? Okay. Can you hear me?
Yes, Livia, we can.
Okay. All right. I thought maybe I was talking to myself. That would be one of the long monologues.
No, it's very interesting so far. Please continue.
So we do have challenges in communicating clear value proposition with performance track record. We come to the company and we say we can develop it, and they say, well, show me the track record, show me the value proposition, and that's a chicken and an egg problem. There are still really very small number of robust commercial solutions for AI. And when I talk robust, that they are broadly deployed, broadly accepted. And one of the problems is that we are constantly dealing with non-standardized data, which varies due to different geological conditions. You know, if I could be using stock price data, historical stock price data, you know, it's always the same. You know, it's the same series, and it doesn't change, or changes because there are certain things that happen in the market. Here, a copper project in one geology versus the other geology, the data looks different, the conditions look, and all this data is still very much non-standardized. AI also, innovation thrives in environment of industrial clusters. So if you go to Silicon Valley, you will have hundreds and hundreds of companies in autonomous vehicle, and they all diffuse and they all talk. So they jumpstart everything. Everything moves fast. Here we're still dealing very much in little silos, smaller companies. We have big companies, and we don't have an easy way of creating that collaborative environment where each party contributes to make move things faster. Now, AI in particular requires access to field data. Yes, we can work on some simulated data, yes, but we actually need to have customers' data. In geophysics, the government is releasing and making publicly available, you know, some geoscience type of data, not just geophysics, geochemistry as well. But when you talk about process optimizations, there are no data sets. You cannot develop something in benchmark and then come to the to potential client and say, look, this is what we can do. We can customize a bit more for you, but we truly understand the data. We understand your workflow, you know, the workflow methodology. We understand the data formats. We understand everything. We just don't have it. And so I'm once again coming back to that question: could we create an AI center of excellence for the natural resource industry in BC? By the way, I'm always happy if you guys want to interrupt me. So this is how we see it and what we've been dealing with as sort of a startup company and entrepreneurs. And perhaps now I can talk a bit more about computational geosciences as a company. So we were actually founded in 2010. It was a spin-out from University of BC. As a matter of fact, every person, every team member that works for our company is a graduate of UBC programs. We were founded with, we have a very strong history of subsurface imaging. That's where we started. You know, our technology, and that's where we brought it forward and improved. We are technical experts in geophysical data processing and 3D modeling. So there is probably no geophysical data that we cannot process, invert. We can do constrained, unconstrained inversions. We can do joint. We can do everything. We actually have a motto that if you collect, we will invert. We will build the models. Our team is multidisciplinary with backgrounds in physics, math, and data science. And that really gives us an advantage in terms of understanding data, integrating, and doing analytics from multiple sensors. As I've mentioned, we've been servicing junior and major mining and oil and gas companies since 2010. I would say that probably in the mining world, there's not one major that we haven't had the project with. And the same applies for oil and gas. And we are seeing this drive now to solutions, innovative solutions that you know, with the eye of how do we do digital transformation, how do we facilitate transition to clean energy. So one of the solutions that computational geosciences provides is what we call prospectivity maps. We actually developed this solution in 2014, before anybody was talking about even AI. We met with one of the major mining companies, and then we met them at PDAC because we wanted to get a conversation going and say, look, you have lots of different properties. Maybe you want to do your evaluation of those properties. How about we will take all the data, and we were trying to explain what we would do with AI. And they brought us and said, look, we are pretty much doing that. And they had a book with 5 transparencies. And the transparencies had different data layers, and they overlaid everything, and they had one dot, and they said, you see, we're actually doing it. So that was the state of the art in 2014. The AI is especially appropriate for these type of problems. Fundamentally, the relationship between mineralization and different geoscience data layers is very complex. And there's no mathematical equation that precisely relates the two. For example, in 3D modeling and inversions, we have very precise mathematical inversions, and we can model it. Here, we just simply, it's very complex, many layers, and we cannot do it through mathematical equations. AI solution actually can learn from these relationships directly from the data. So CGI's prospectivity maps are based very much on our deep expertise in geoscience, data, and AI techniques. In particular, our expertise in 3D subsurface imaging allows us to incorporate every kind of geophysical inversion as an input. And I can tell you that most of the data is noisy, unleveled, difficult to work with, and it requires incredible understanding and skill set to prepare the data, to understand it, and to use it as an appropriate input in order to allow AI to actually start generating prospectivity maps. We actually can use up to hundreds of layers of data. We know how to address the problems of very sparse data, because sometimes, there are very few areas with known mineralizations. Sometimes when there is insufficient data, because we have expertise in models, we can do data augmentation. And we have custom designed neural networks, we call it VNets, for this particular problem. So CGI work generates maps at local and regional scales. Many companies will want to use this for targeting, so they will want to go into very localized areas. Others are actually looking at the regional scale because they are trying to rank different projects or do a quick look over a very, very large area. We can do countrywide and actually continent-wide scales. We've done all of those. And again, we live and die by offering our services and generating revenue. And so we have clients, we've done this work for clients in Canada, Japan, and Australia. I don't know how many technical people or geologists or geophysicists are in the audience, but I am going to show another solution, which is another AI solution, which is IP signal detection from airborne EM. So in the industry, companies do many different geophysical surveys. Induced polarization is one of the sort of very important surveys, especially as one looks for chargeability. Very often copper is associated with chargeable sulfides, etc. Most of those surveys not most, all of them are ground surveys. They are more expensive, and it means putting lines, and that in essence limits the size of the surveys or the time required and the cost associated with it. It has been known for a while that IP signals can be detected from airborne electromagnetic decay curves. Now, it is very difficult and time-consuming to do it manually, and very many subtle features are actually not visible by eye. So again, this came from our clients who said, we have remote areas, we have EM surveys, we do not want to go to the area to do ground IP surveys. Can you guys come up with something? AI was the right approach to this. Again, we relied very much on our modeling capabilities. There wasn't enough data, so we generated thousands and thousands of physics-based 3D forward models in order to allow our AI systems to train and identify IP signals. We developed a threshold probability that the IP that there is the chargeable body there at between 80 to 90%. And again, we started applying this solution to large field data sets. So that's another one. And since I said that we cover discovery and operational optimization, this is the last solution that I want just to show what computational geosciences has done. And that's the multi-sensor drilling analysis. This is a company that earns its money by drilling holes, putting dynamite and blasting benches during mining operations. They came to us saying that they have certain measurements from the drilling, so like air pressure and RPMs per minute, etc. They wanted to predict rock properties and mineralogy. They definitely did go and measure the mineralogy where they were drilling. The idea was that they will optimize drill patterns and resource extraction. So as they start this process, if they can interpolate between drill holes where there's no mineralization, they can have a, they can go on a larger matrix where there is a lot of mineralization. They will try to blast in much, much smaller pattern. So they gave us the data. You can look at the input and the output. And the idea is, again, cost savings. It's on-the-fly assessment while they do the work, and reduce waste drilling. And what we ended up generating, you can see that some of the data, you see different dots, and as always, the reality hits you, and all of a sudden you discover, oh, well, they measured the mineralization next to it, not exactly on the spot. So all this understanding of data and how you can deal with sparse data and how you can tie everything together in order to run AI is very, very important. And then some drill holes were used for training, some were used for validation. And in the end, we generated a map, which for them indicated where was likely mineralization, and that's how they would space their dynamite blasting activities. So these are not all that we have. Of course, we have some other solutions and AI solutions in seismic, but I really think that we have now a number of technology companies in BC, here in Vancouver, and we are complementary. We can feed off each other. We can learn from each other, but we need a village. We need a village around us. We need to talk to to understand the needs of the industry. We need them to define the problems. We want to talk to the techs of this world. We want to talk to juniors of this world, and to have that diffusive type of activity, because that's really the only way that we can win and be the best. So that's all for my presentation.
Thank you. And, you know, again, Livia, that was, you know, it was great to understand some of the detailed technical capabilities that we have right here in our backyard, and continues to amaze me, you know, when I work with some of our mining clients, and, you know, in the role we play as they start to leverage data and start to putting in, you know, mine of the future programs or other programs, you know, the ability to bring together some of these anchor clients with the, you know, with the focus that companies and organizations like yours provide. So looking forward to doing that in a continued fashion going forward. So thank you again.
Thank you.
Next up is Martin Heist, is VP Geoscience at MineSense. And Martin is a geologist and material sensing scientist with a keen interest in sensors and sensor fusion across the mining value chain. As VP Geoscience at MineSense, Martin is supporting the creation of data models to generate value from the deployed MineSense sensors, as well as supporting research into new sensors to enhance the capability of these products. Welcome, Martin, and I'm looking forward to you dazzling us with the work that you do over the next 15 minutes or so.
I'll give you my best. Just to confirm, can you see the presentation on your side?
Yes.
Excellent. Thank you. Thank you for the introduction. And I'll talk through where MineSense is and where we are going to, and how MineSense really sits. We're focused on mining, of course, given our name, but we sit at that interface between collecting more high-resolution data in the mine and then using that data with AI to deliver better solutions, more value to mining companies. And I have a deck here where I'll talk through a few of those examples. So up front here, we got one of the excavators on which we're installed, and we can see some of the sensors that we integrate. And you'll see a lot more of that on the next few slides. This picture is actually from Copper Mountain, which is one of our strong supporters in BC. So MineSense, the company profile. So we are a mine data services company, and we're based in South Vancouver here, where we have our offices, and also where we do a lot of the manufacturing of the sensors we build and then supply to base metal mines across the world. And so our whole work is really on developing these material sensing tools that can be deployed at the mine face or on conveyor belts. MineSense originated out of a PhD study on bulk ore sorting at UBC. And that engagement with UBC is continuing to this day with further research projects that are happening. Now we are taking what are essentially lab sensors and putting them on digging equipment and on conveyor belts in a mining setting. That's not what these sensors were meant to do. And so we have been spending years on sensor ruggedization, so making sure they survive, and then developing pipelines to convert that high resolution sensor data into value for the mine. And then also making sure that that data that's collected at very high frequency is properly stored and aligned with other data sets. This has taken a long time, and we have only really been possible, this has only been possible to do that thanks to very generous support from a number of government grants. So I think that support from very specifically SDTC and IRAP and SHRED has been key to get MineSense to where it is today. That's very much appreciated. Now we're at this point where we do have a set of sensors that we can install on equipment that will survive, and we can convert it into information that makes value at a number of commercial sites across the world. So Copper Mountain is one, HPC is another in BC, for example. And so we're getting lots of customer demand, and now we're entering, or we entered the space of aggressive growth to try and meet that demand. But just to want to really be clear that this has been a collaborative effort between Government of Canada, UBC, and then MineSense to get us where we are. Without that, it wouldn't have been possible. So what is MineSense all about? At the moment, mining operations today, they are limited in the resolution at which they can mine, because we have this quite sparse drill hole data set based on which the ore body is divided into blocks, and a whole block is then sent to either ore or to waste. There is not much else we can do because the resolution of data is not available. We, however, know that nature isn't as homogeneous. There is a higher heterogeneity in there, and that entire block, if it's waste, it likely has some ore potentially, and the other way around. And so by being able to visualize that ore and waste at that resolution, we can actually exploit that natural heterogeneity that is available as nature laid it out for us. And so the whole MineSense solution is about sensing ore and waste and other parameters at the resolution of a bucket, and then separating it out at that resolution of that bucket correctly between what should go to ore and what should go to waste. In this example, we're looking at a whole block of waste, which would have been sent to the waste dump, where now MineSense technology allows you to pick out certain parts and send that for processing. So making sure that sulfides don't come from the waste dump, for example. This has lots of benefits, and we'll see through the presentation. So MineSense offers sensors, but also other components that make it into a solution. So we do talk about the MineSense solutions, which combine hardware, software, and cloud infrastructure. In terms of sensors and systems on equipment, we have the shovel sense system, where we can install on, we have installations on cable shovels, on hydraulic shovels, and on front-end loaders. And you can see the systems here near the brow of the bucket, integrated within the bucket. And they allow, as the rocks roll into the buckets, we're using X-ray fluorescence, is our main technology that we're currently working with. And they allow to then assess the grade of each bucket as the rocks roll in. And they then allow to use that information in real time to sort ore from waste. This system is either able to provide grades to the operator through a HMI that's in the operator cabin, or we can be directly integrated, as we are actually with all our mines where we operate, with the fleet management system, so that those decisions are made automatically. So that's the shovel sense system. You'll see most slides will talk about shovel sense system. We do have also a belt sense system, where we take the same sensors and then place them over the belt. Once you're in the processing plant, material rerouting becomes more difficult. Still possible if they have a diverter on the belt. But by having it in the processing plant, you can affect change in the processing parameters. And you also, what is really exciting from an AI perspective, is that you can then link that response in the plant with plant variables, say, for example, copper recovery. And once you have that relationship built, because it's the same sensor on the shovel, you could then start predicting copper recovery in the mine, which would be highly beneficial. Now, these are all sensors, and we call them sensors at the edge. We have built at MineSense this digital platform that pulls in the sensor data from the sensors on the shovels and on the belts, and combines it with other data sources, be that drill hole data, processing plant data, and nicely aligns all of that to a common level where it can then be used to learn and to predict. So we have essentially developed that gateway to the edge, where we combine all the data and then allow third parties, that can be mining clients or other services providers to the mines, to interact with those data and then make additional value out of that. So let's talk a bit more about that digital platform, because I think from an AI perspective, this is critical. And Lydia also alluded to this, is that first collecting these super high resolution data, be it on shovels or conveyor belts, is important. But then it's what you do with it and how do you align it with other datasets. So the first thing, okay, we have the real-time data collection. That's nice. Then we have a solution to take that real-time data and use it for material classification, come up with decisions, and so divert trucks in real time. But then the same data is being streamed to the MineSense cloud, and it's there processed using machine learning algorithms to come up with a number of services. And so those components together, we are referring to as the digital platform. Over top of that, we do have a number of capabilities in terms of streaming and loading of data. So I'm sure everything goes in there and then can also flow on to other parts. So through data integration APIs. We have a number of dashboards that feed off that platform so that people at MineSense, people at mine sites or third-party vendors can interact with the data. And then we can really release on top of that data the AI that we built. And this leads into services that then can be provided from these data capabilities. And now the next few slides will talk through examples of how those services can deliver value at sites. We'll very specifically be looking at having grade measured by bucket location and how that helps deliver value. And then also once integrated with fleet management, tracking through the processing plant, how that can deliver value, because that's really two of those where then AI over the top can add additional value. So let's first look at sorting at the face, which is really the central part of the MineSense system. So the shovel sense or a shovel enabled with shovel sense will get for each bucket this type of spectrum. So an XRF spectrum where we can then look at the individual peaks and convert those into a prediction of grade that can then be used to classify the material as ore, waste, low grade, or any other class that the mine wants. So there is a calibration step there, which MineSense and the mine work together on collaboratively. Once we've taken that bucket and classified it, then there is a step of integration with fleet management to make sure that a set of buckets into a truck are compared against what the original mine plan thought it was. And if it's different, then that truck is diverted to a different location. So that's the core of the shovel sense system. That's typically why a client would install shovel sense. Now, we do get add-on insights as a free extra from all of this, because we are collecting bucket grades with our XRF system, but we also have a high precision GNSS system integrated from a third-party provider here in BC. And so we get for the grade per bucket, we also get a location. You'll see some nice visuals from that. We do get, as you can see in the spectrum, so you got the spectrum has many peaks relating to many different elements that produce these fluorescence peaks. And that can then be used for relating with other variables, be it copper recovery, be it hardness. And then we are working on adding or augmenting our sensing capability with other sensors that would give us insight into mineralogy and particle sense. And now the next slide, we'll be looking at an example of what this looks like. And then I should mention, sorry, we also have operational data, of course, because we get really deep insight into how many buckets are taken, what is the fill profile, what is the swing speed. So, and a lot of that would also be used to create additional data insights. But going back, so now we're looking at an example of what happens now that we measure bucket grades for each bucket. And beyond just diverting things in real time, what happens if we now aggregate this in 3 dimensions over a very long period of time? just a single example here. Every dot in this image is a bucket scoop, so one full bucket of material. And it's now first color coded by the original mine plan design. So all of this material, all the blues were waste, would be sent to the waste dump, and all the reds are high grade, would be sent to the crusher. And I want you to keep an eye on this odd looking polygon, because there is some ore that identified within the waste zone. If we let this run and we change the color coding, now the dots are colored by the copper grade as it was measured by the ShovelSense system. And so that strange looking polygon appears to be a vein running through that waste domain. We can see similar structures here, here, and also there. All of this was past waste originally. And so I think that's the true power of going to that higher resolution, the bucket resolution, and then using that to sort ore from waste. And now that is all interesting at that real-time sorting. But of course, now that you have these data integrated over time, the next challenge is, and that's something what we are actively discussing with Minds, is how do you use this information on one bench to better guide the plan on the next bench? Because knowing the structures exist in the ore body, could you affect change on the big directions on the next bench to maximize ore recovery? I think that's where truly machine learning can shine. And then just looking through across a number of benches, seeing good correlation or good repeatability of ShovelSense readings across that, which is good as well. So this is that one example. So this is where we were. Now it doesn't stop here. There is a lot more value to be gained. And just highlighting here, taken from CRC Ore, so an Australian report on items or parts in the mining value chain where sensing is done and where it can add value. So we'll be focusing on these because this is where we believe a combination between sensing at the face and other data streams can deliver value to the mining process. So we'll look at a few. I won't read through these, but of course, when we would focus on the operational data by doing condition monitoring, looking at operator effectiveness, there is lots of value we can generate there. With bucket grades and location, we had an example of that high resolution modeling, how that could help. But then we'll have another example looking at material tracking next, linking that with mill feed grade. And by using more information that's contained in the spectrum, can we relate to plant parameters and improve recovery? And also by looking at these additional characteristics of mineralogy, say oxide versus sulfides, knowing clay content, that could also deliver lots of benefits across these different steps in the mining value chain. But these are definitely jobs to be done. And I think the key message here is that that's not something one company can do. This is where we need multiple companies, and we need that collaboration to be able to tackle all of these by bringing the expertise of one company, say, on sensing solutions and building a platform, but then bringing the artificial intelligence knowledge or the metallurgy knowledge from other companies to tackle these jobs together. And so, as mentioned, we'll have one more example on tracking to the mill, because it is a nice example of showing that measuring at the bucket is nice, and it has lots of other flow-on benefits way beyond mining itself, and also to processing. So in this situation, we have mine, a stockpile. We got 5 systems digging in here. 3 of those are enabled with ShovelSense. And then processing circuits, they have an on-stream analyzer that measures the copper grade on the stream coming out of the mill. and they also have tonnages that are going into the mill. And so we can compare copper grades and tonnages measured with shovel sense, and tonnages just from the scoops, of course, with what we measure in the mill. And so this is looking.
Sorry, Martin, it's Jamil. Just a quick time check. I want to keep it on track. So just making sure that you're on track here.
One slide after this.
Okay, perfect. Thanks.
So we got shovel sense grades in blue, the head grades from the AOSA in red. This is at hourly level, tracking really well. The nice thing, and at the bottom here, we're looking at the differences between weights going into the mill and weights measured by shovel sense. And so when there is a gap, we haven't covered the entire stream that feeds. Now, what is very neat here is, of course, that we have these massive variations that we are measuring ahead of time with shovel sense. And now what could the mine do, knowing the copper grades that are going into the crusher? Are there changes they could make with how they feed from the stockpile, or how they change digging rates to better normalize this feed? I think that's one of the obvious examples of how value can be created. Now, the other one is then, can we, now that we can relate an XRF response on a bucket with something in the processing plant, can we relate it with other things, be that copper recovery, hardness, reagent consumption, and then start predicting those much earlier in the value chain, and then change the strategy to improve on these parameters. So to bring that all together, I think essential ingredients to maximize the benefit of AI in mining from a MineSense perspective, of course, is that integration of data sets is key. I mean, a lot of this additional value where you can truly use AI can only come, as Livia also mentioned, is that you do need to have all these different data sets aligned in a common database. That's why we have spent a lot of time on the digital platform, time and effort, but it's a key to get there. Smart algorithms to align datasets speaks for itself, and of course then AI to gain knowledge from these aligned datasets, because those relationships are not all linear one-to-one. The other part, which was alluded to many times too, is collaboration. I think there are so many jobs to be done, and this can't be done by a single company. I think being open to share data, store them together, and then have multiple individuals, companies work on those data sets to create the value. And last but not least is training. So we do, the mining industry will need more people who are across both AI and mining to generate the value out of that combination. That was it for me. Thank you.
Great, thanks, Martin. These are some important and big use cases at the mine operation level. So glad to see the innovation that's happening over at MineSense, and looking forward to connecting with you again as well. Thank you for the presentation. So we're plugging away here, and so next speaker is Clinton Smith, co-founder and CTO of Minerva Intelligence, a company he co-founded together with UBC's Professor David Poole in 2017. Clinton has a Master of Science in Geochemistry and a Master of Science in Computer Science with a focus on artificial intelligence. Clinton worked throughout the world for the Anglo-American Corporation for 25 years before moving to Canada in the year 2000. Since then, he has continued to work globally in both minerals exploration and in software development. Clinton, good to see you again, and over to you.
Thank you very much, Jamil. I will share my screen. And start the presentation. So yes, good afternoon, ladies and gentlemen. Thanks for staying for the last presentation. My presentation is entitled Using AI to Analyze Multi-Element Drilling Data, a Marriage of Machine Learning and Cognitive AI. So Minerva Intelligence is a Vancouver-based software company specializing in applying knowledge engineering and cognitive AI to the earth sciences and to climate change mitigation. We are organized really into 4 sections or departments, 2 that are addressing vertical applications in the climate risk area and in the economic geology area and mining. And these 2 vertical areas are supported by a powerful software team and a powerful geospatial team. As you can imagine, our products are in both of those categories, economic geology and climate risk. The Solace product in economic geology is a data preparation and an alignment product. It prepares data for interpretation in 3 dimensions, which we'll have examples of in Driver today. In 2 dimensions, surface exploration data in our target application. And these all 3 are integrated with a document management system, because most of the knowledge that we deal with in cognitive AI systems comes from knowledge documented by human beings, which is then integrated with knowledge that comes from machine learning. So artificial intelligence is really developed in a number of different categories. And the 3 important ones to think about are unsupervised machine learning, supervised machine learning with a bit of human input, and then cognitive AI, which we typically characterize as problems that require thinking. And this includes explaining the results of the output of an intelligent machine. Typically, machine learning many of the machine learning triumphs over the last 10 or 15 years are the kind of things that machines achieve that human beings achieve, like vision and speech and hearing, in fractions of a second. And machines do that pretty well. But the big challenge is getting machines to work on things that we as humans ponder about for days or weeks or years sometimes to get right. So this slide, I want to say that machine learning has recently enjoyed the limelight because trust requires explainability, explainability requires semantics, semantics require terminology standards, and terminology standards are really hard. This subject is addressed pretty well in a 2019 book by Gary Marcus and Ernest Davies. Gary Marcus lives in Vancouver. Rebooting AI is a really good read. I'd like to show you a quick video now on what Driver, one of our tools, does to marry machine learning and cognitive AI.
In order to find mineral deposits, companies spend millions of dollars collecting drilling data. They then analyze the chemistry of their drilling samples for 30 to 40 elements. But because of time and budget constraints, they typically only focus on a few of the elements analyzed. Mineral deposits are complex, but they have multi-element geochemical signatures that can be used to enhance deposit understanding. These geochemical signatures are useful for exploration, mining and metallurgy, and environmental applications. But modeling these multi-element geochemical signatures is costly and time-consuming, and it's impractical for humans to model everything. Driver by Minerva Intelligence was built to solve this problem. Driver uses massive cloud computing power combined with cutting-edge artificial intelligence to quickly and accurately model mineral deposit geochemistry in 3D. Unlike other software, Driver uses exhaustive modeling to create tens of thousands of block models of every element in the dataset. Driver then uses artificial intelligence to test every model and automatically find the chemically enhanced zones that most closely represent reality. Driver also calculates how every possible combination of elements spatially overlap, allowing it to reveal the true geochemical complexity in your deposit. The Driver results integrate Minerva's intelligent cognitive reasoning software to identify meaningful comparisons between your deposit and others from around the world. The driver system can be accessed online from anywhere. It interacts seamlessly with existing geological modeling software and harnesses enough computational power to process even the largest geochemical datasets in a matter of days. Driver helps you discover geochemical features and patterns in your deposit using only data you've already paid to collect. For more information on Driver or to try it out for yourself, please visit our website at minervaintelligence.com/.
Okay, thank you. That's a quick summary of what Driver does. There's a lot going on underneath the covers, which we won't be able to address today. But in a nutshell, Driver uses supervised and unsupervised machine learning and cognitive AI to expedite thorough interpretation of multi-million-dollar databases of geochemical drilling results, which are typically only interpreted for the economic elements and sometimes sulfur and a couple of metallurgically important ones. The unsupervised learning step in Driver uses up to 1,000 CPUs to run thousands of models, interpolating different anisotropies and subjecting them all to spatial cluster analysis to identify where the zones of enhancement of all the elements are under different anisotropies. The next step involves a supervised learning stage where the grade, volume, and anisotropy variables for all these thousands of models are analyzed to determine the maximum likelihood anisotropy. And this is done independently for each element, and for each element independently in different parts of the body drilled, so that one can identify an anisotropy in the northern part of the body, which is different from the anisotropy in the southern part, and take those into the model. One is then able to combine, as we saw in the previous video, where the elements are, potentially what host rocks they're in, and what elements overlap with each other to make very refined and complex descriptions of the deposit, which are then comparable in the cognitive stage of our reasoning with either thousands of deposits in other parts of the world or mineral deposit models, which are used for classification. And these similarity rankings are very important to geologists. It's typically what they pay consultants to do when they come out onto their properties, is call on their experience to say what the target being searched for looks like. And then this is all supported, of course, by human readable explanations as to why your drilling results look more like one deposit than the other. So as examples that we've been fortunate to work on in British Columbia, and thinking about how what Livia said about this being such a rich environment to develop world-class technology, we'll see examples today from the New Afton gold mine outside Kamloops, the Bruce Jack, sorry, a copper gold porphyry, the Bruce Jack gold mine in northern BC, and the Saddle North copper gold porphyry in northern BC. Just quick looks at them. This slide is to explain to those who don't know much about geochemistry and mineral deposits, is that they are very complicated. In the scientific literature, there is, over the last 10 years or so or more, attempts in the literature to quantify the enhancements and depletions that we expect as a function of their position in or outside the deposit. These are pretty general documentations because it's been difficult to quantify that information comprehensively over time because it takes so much work. However, once done, it's very important to be able to compare this internationally with other scientifically documented mineral exploration and mining results. What we see here is this is a documentation 2015 of porphyry copper deposits and VMS deposits on the right-hand side. So we talked about examples. This is not such a well-prepared graphic, but it shows powerful information of the copper zonation in the New Afton porphyry copper deposit. So in the top left-hand corner here, we just show the input drilling data, which is uploaded into Driver, and really at the click of a button after selecting a block size, Driver will generate and identify all the enhanced copper zones that it sees in that drilling. This is the main ore body in purple here, and the other colored ore bodies are satellite, if you like, copper concentrations. the concentrations and volumes in cubic meters here. The main ore body is about 125 million cubic meters running at a concentration of about 0.5% copper. And these are satellite copper volumes that have been identified. The accuracy of these is a function, of course, of the density of drilling data, and the less dense your drilling data, the less accurate the volumes are. And then in the bottom left-hand corner here, we see the same drilling data and the zinc zones. Each colored zone is a different zinc zone, and it must be clear even to non-geochemists that zinc is enjoying a completely different physical displacement than the copper. Now, if we bear in mind that all these samples, and there are over 100,000 of them, have all been analyzed for 36 or so elements, there's an awful lot of work to be done if it's done by a human being. But if you hand it over to a properly programmed AI system that includes those steps that I spoke about, where there's a kind of a computer vision involved in identifying these positions, you end up with a lot of geochemical data that can then be fed into the cognitive side of describing exactly the chemistry and zonation of the deposit. And then if you have other deposits that are described with equal discipline, being able to compare and rank and contrast them. So indexing this work back into the scientific literature, here's the Halley diagram of typical porphyry zonation, 2015 economic geology. And here we see listed, highlighted in red from a table in that publication, the enhancement levels that we have identified in the New Afton porphyry copper gold deposit. So this is a great step forward in both understanding New Afton and validating the international documentation of what one should be expecting around a copper porphyry deposit and can use to extend it or to find new deposits in that environment. So it's very important then that geologists are able to compare their results to global knowledge of mineral deposits. Minerva uses knowledge representation and reasoning technology to achieve this at scale. And there are a lot of moving parts here. We have to be able to summarize knowledge from the scientific literature in a very disciplined way. And we used the so-called ontological technology to do that. Ontologies are specifications of meaning, and these specifications of meaning are built upon taxonomies. So in order to do the work we do, we have to have standardized taxonomies for rock nomenclature, mineral nomenclature, geological time, structure, elements of the periodic table, etc. All of that goes into the mix here and is used to extract knowledge from the scientific literature. All of that knowledge is represented in structures called semantic networks, which are a lot more powerful than simple relational databases. They also go by the name of knowledge graphs. We understand those interchangeably. So here is a map view then of the substantial knowledge base that Minerva has access to, because we've been building it up over many years. And the use of standard earth science terminology is absolutely critical for interoperability between all these data sources. So what we've had to do over time is align the terminology of the Osman database, which has got over 1,000 mineral deposits, mines described in it, the Geo database for Europe, and then some of these very big databases are actually mineral occurrence databases rather than mineral deposit databases. And you can see they're very big, 5,000 in New Brunswick, Nova Scotia, 10,000 in British Columbia. These are all now interoperable because they've followed the same standards. Once you do that, you can then generate, using the cognitive side, these very valuable rankings. So this is a ranking of New Afton against 92 USGS deposit types. And here's a ranking of New Afton against over 1,000 deposit types in Australia. By clicking on a link in this report, the system explains to you why it thinks that New Afton looks a lot like a volcanic hosted copper, antimony, arsenic deposit. And you may think, well, it's a bit disappointing that this system is only ranking porphyry copper gold deposit as about the 5th most likely match out of 92. And the reason for that is explained in this system. And you are able to update and take the advice given by the system to update either knowledge you have about your deposit, which will typically take it closer to what you think it is, if you're thinking correctly, or you're even able to change the mineral deposit models if you think they're wrong. Same thing happens when you're comparing mine to mine. We don't have time to go into that too much now, but what we really do need to go into is how important standards are to cognitive AI. And I'd like to show my second video now, which is to do with how the European Union is leading the way globally in the adoption of standards to make data interoperable across the world. So with that, I'll start this video.
All European countries make and use geospatial data, such as groundwater, transport networks, population, land use, and air temperatures. And each country has its own specific way to describe this data. But our environment doesn't stop at the borders we make. Our rivers flow through multiple countries. We share mountains, lakes, roads, and the air we breathe. This becomes even clearer in times of crisis, when the right choices need to be made quickly. Take Iceland, for example, where a volcano erupted in 2010. Several countries needed data on air pollution and air quality. This data had to be comparable across borders for decision makers in the health and transport domains. Or look at this region. Extreme weather flooded an industrial chemical plant, contaminating the river. Downstream in the neighboring country, people use the water for recreation and agriculture. Governments and local authorities need to have data and timely information to help predict the impact on their community. But data is not always readily available, or the data is created using different standards. Therefore, hundreds of experts from across Europe have worked together to define common standards to describe and to share the spatial data. The result was a European legislation called INSPIRE, with the goal to create an infrastructure for sharing spatial information between public authorities and Europe. INSPIRE defines common standards for 34 spatial data themes, including administrative units, transport networks, protected sites, elevation, population distribution, energy resources, utility and government services, and natural risk zones, to name a few. In some cases, information is collected for the first time. When this happens, the INSPIRE standards help to do this in an efficient way. INSPIRE allows spatial data from different countries to be found, shared, and used more easily. Information is available through an online portal. Users can be confident that the data they get can be readily combined and integrated, and public authorities will be able to take more informed decisions and at the right time.
So Minerva has actually worked very actively with these standards, and in the area of landslides, we've actually won an award, the best presentation or best use of these standards in 2019. I'm going to have to rush through these slides. I wish to say that governments in North America are catching up with the European Union and are issuing contracts in support of these interoperability standards. And we've been fortunate in the last year to be awarded 3 significant contracts, all to do with standardization in order to achieve better science. And at the same time, they are preparing data for AI. So flooding, geology and minerals exploration in April, and in May, hydrography. In terms of the exploration and mining industries themselves, we're not as reactionary as some people think. So for 20 years now, we've been operating under the standards implemented by Instrument 43101 for documenting exploration and mining. Those don't specify terminology standards, but they make a big step towards AI by systematizing the kind of information we have to put in each section of the report. It so happens though that the PDAC is at the forefront of encouraging the government authorities in all the provinces of British Columbia, of Canada, to standardize how exploration companies report their results so that they can be interoperable across boundaries in Canada. This is the results they are compelled to report as part of their licensing obligations. So I'd encourage you to have a look at these guidelines that the PDSC is pushing government on, which are available on their website. Just a few slides to quickly give you a taste for what the other deposits look like. The New Gold, now Newmont, have kindly made available to the public on the new GT Gold website, not New Gold, all the drilling results for Saddle North. We have those and we're actually working through them now on Driver. This is what the copper zone looks like in pink and the zinc zone around it in purple. This is on the SAS interface. Driver can be used anywhere in the world with anyone who has an internet connection. And then to almost close off the presentation, I'd just like to fade you through what Driver processing does to over 200,000 samples. This is the drilling results from up until last year for the Bruce Jack deposit kindly provided us to work on by Predium. And there we see the input drilling results, what Driver does with respect to blocking them, thousands of block models like this that are analyzed, and the gold zones identified and all the other 33 elements, boundaries drawn. There's the gold zone, which very closely matches the geostatistically determined gold zones, which took a great many months and years for geostatisticians to develop. Here we see the zinc zonation superimposed on top of that, and the barium zonation around it. Barium is often a proxy for sericite, which has a significant effect on grindability of the rock, rock hardness. So this kind of geochemistry is useful not just for exploration, but for geometallurgy, mining applications, and obviously environmental aspects of mine planning. So my last slide places on the table the fact that all of this knowledge engineering work happens within two paradigms. The one is the kind of closed loop paradigm of e-science, which we don't have a chance to talk about now, but basically old knowledge develops new knowledge and it recycles like this. And the other paradigm we operate within, which will be familiar to a lot of the AI audience here, is Tim Berners-Lee's semantic web paradigm with trust sitting right at the top here and Unicode characters coming in at the bottom. And this diagram just illustrates where the different components of software we've developed over the years sit in the semantic net paradigm. Thank you very much. Oh, I must stop my share.
Well, thanks, excuse me, Clinton. That was definitely, what's the word I'm looking for here? Very encouraging that we could start to gain some of these insights, using those tools. So I think the key message that you're delivering is you need more data, right? And more data to be shared across the sector. So hopefully that's, what's that?
Standardized data.
Standardized data and standards.
We can't all sing to our own hymn sheets.
Absolutely. Well, thank you. And so I think we're in the final stretch here. We're going to do a quick panel. It's going to be facilitated by by Kendra Johnston, who's the president and CEO of the Association of Mineral Exploration BC. And I know we've got 15 minutes here, but Kendra, I know you've prepared some very pointed questions for the panelists, and maybe you can hit them up with the key ones, and I'll hand it over to you.
You bet. Thanks so much, Jamil. And I'm going to ask you to stay on the screen because you are one of our three panelists today. I will also ask Sean Baker to turn his screen on, and Steve Lowry. Sean is the director of the Mineral Deposit Research Unit out at the University of British Columbia and has experience both researching and publishing results using AI and machine learning. And Steve, of course, everybody met earlier in our session today as we kicked off, and he is the lead and founder of AI in BC. So thank you, all three of you, for joining us today. So I do want to jump in. We've got 15 minutes, and if there are any really pressing questions from the audience, please do throw them in the chat function. We will make those a priority. Otherwise, you are stuck with my questions, which I promise will also be entertaining. But I'd like to give each of you first an opportunity to talk a little bit about what you do, your experience with AI. We've had a great session today that's touched on the entire ecosystem, as Michael Goehring called it earlier today, from prospecting and exploration all the way through to operations and metallurgical results. And then some of the somewhat periphery parts of our mineral exploration cycle, mining cycle as well, where we use some of those results in things like financing and that kind of thing. So Sean, maybe I will start with you, having some experience on the academic side, doing some research, working with AI. Where do you see AI coming in most often within geological research?
It's obviously coming into a lot of the things that we deal with, particularly some of those larger data sets that Clinton was just talking about. And as you know, I'll be what machine learning people call a domain expert, and as domain experts, we can get bogged down in these really large data sets, and that's where AI helps us. You know, a couple of experiences on the negative side, having dealt with some spectral data and some machine learning, and to the machine learning people's credit, they said, you know, unsupervised machine learning is really dangerous. But I gave them a large data set, and they looked and said, oh, there's some really interesting results that have come out of this. You've got to come take a look. So I took a look, and from a geological perspective, they made absolutely no sense, even though they had these very distinctive clusters. So once I went away and looked at what clusters I'd found, I determined they'd managed to figure out what date the data was collected on. So that was kind of interesting that it came out of the spectra, but utterly useless from an application point of view. On the plus side, when you have really strong supervision and large data-rich environments and good training data, you get incredible results that no human could typically produce. So that's sort of my experience, is that having both a domain expert at the interface and being able to translate between the data scientist, who's often very much so in the numerical space, but can't translate it into a language that the domain expert can understand. And those translators who sit between worlds are often just really critical for enabling us to maximize the value of the results. So that's, I'll stop there, otherwise I'd go on, but that's sort of my experience. And I think that's a really critical part of those translators who can take a domain expert idea, put it into a numerical context, whereas a numerical expert can pick that up and then extract as much value as possible out of it.
Yeah, no, I think that's a great example and a great learning to come from big data sets. It's something that we certainly all struggle with, and having that common communication and common language is really important. Jamil, I want to go over to you. You guys have some really neat things happening at KPMG. You are sitting in a room that is very much focused on innovation, new ideas coming through there all the time. I'm sure there's lots of things that you can't talk about that you've seen come through your doors there, but can you tell us some of the exciting projects that you have seen come through your doors?
Yeah, thanks. And you know, this has been my background for a good part of a year and a half now. So you know, it's a constant reminder for us of the innovation. I think I mentioned earlier on in my opening remarks that we ourselves as KPMG are transforming our services on, you know, how we provide audit and tax services to our clients. So, you know, we have applied machine learning and artificial intelligence and robotic process automation into our traditional fields of work. And we've taken some of those learnings and partner with organizations in our innovation lab, you know, organizations such as MABC and BC Tech and others, Microsoft and other large organizations, to take some of these innovations to our clients to solve traditional processes, right? And so from a mining perspective, I mean, we work across the board with organizations to set the strategy, right? To set the strategy on how do we start the innovation culture within our organization. It's a different mindset. It's a different investment mindset, decision-making mindset, and as well, it takes a different set of skills and talent. And so what is the strategy behind that? And recently, with some of our mining clients, we have been looking at, you know, how to implement some of these techniques, whether it's, you know, around advanced process control or mine metallurgy, or on the connected worker side of things. You know, how do you start building a strategy around the data but as well as look at some of the behaviors at the operational level at the mine site. So it's really exciting times. You know, the algorithms, I think Clinton mentioned that, are as good as, you know, them being trusted. So really, you know, standardized, trusted data is where we're heading towards as we apply these techniques.
Mm-hmm. Yeah, that's a really interesting point on the innovation mindset for and going into sort of the R&D side of things. For many years, we talked about sort of the exploration component of the industry being the R&D to the miners, and in some respects they still are from a geological perspective, but not at all from a technology perspective. There's just so much big thought going into some of these projects and new technology that isn't as accessible at the lower end of the spectrum. So some really neat things happening there, and certainly a shift in the way people are thinking about things. Steve, I want to go up to you. You are not as familiar with the mining industry as some of the other folks in this group. So, however, far more in depth on the AI side of things. So where do you see the connection, and what's your perception of the conversation today? And I'd also like you to touch on Horizon. Jamil talked about it a little bit at the beginning. Can you tell us a little bit more about what that is and where you see that going and what it might mean for the mining industry?
Yeah, no, happy to. So I've really been enjoying the discussions today, covering, you know, such a wide range of topics. It's really actually great to dig in on the details when you see the specifics, you know, those layered data sets and visualizations of the things that these, you know, innovative companies are working on. It's you know, we know the companies of the industry association, we know about different companies, hear their name, hear roughly what they do, but it's a great opportunity to get a close look in. So, you know, how we often work with companies, we find ourselves supporting the talent side of things. We haven't talked as much about that today, but all these companies, you know, who are innovating in the AI space really need talent, you know, top-notch people that are going to get the story right, who are going to get, you know, apply the best science we have to, you know, very commercial situations. And so what we do a lot is helping companies, you know, small and large, you know, find talent. And one of the initiatives to do that actually is Athena Pathways, which is an initiative to train 500 women in AI. So addressing kind of the gender imbalance we find in the industry, and this has been supported by the Digital Supercluster, and we've been, you know, really successful in it so far, training 400 women and continuing to grow with a new program just being released right now, actually. To train, actually, which ties into what Sean was saying, training translators and mid-career managers. We've just launched a new initiative to try and you know, find individuals who have, you know, good experience in their career as managers, you know, product managers, project managers, software managers, give them a deep kind of learning in AI and, you know, a sort of crash course through UBC, SFU, Northeastern, and then, you know, put them out into the AI settings where they can kind of translate this for, you know, on the one hand, they understand how businesses operate. And on the other hand, now they've picked up the skills on the AI side and can work with those scientists coming out of, you know, school or otherwise, you know, PhDs that are, you know, crunching the hard numbers and figuring out, you know, the science of it for the company. So there's just a lot in that space that needs to be sorted out, as it's still early days for AI. So as an industry body, we do a lot of work in that area, and love to contribute with any folks on this call. If you're looking for talent, come talk to us. And then, yeah, just around Horizon, you know, touch on briefly. So this is an initiative that we've been working on for actually a couple of years. It came out of you know, work that Alan Mackworth had done when he was at UBC. He's a professor emeritus, and had just seen, you know, these centers of AI excellence being funded by the federal government through the Pan-Canadian AI strategy and through CFAR. You know, there's some great work that goes on at the Vector Institute in Toronto, and Mila in Montreal, Amy in, you know, Alberta, Edmonton, and, you know, looking around, you know, BC doesn't have exactly that, right? And there's a real potential here to bring, you know, all the great people that we have working in the space. Like, universities have top level researchers, you know, truly UBC, SFU, you know, I think UBC is top 25 in the world in terms of computer science, you know, publications and otherwise, and attracting big names. like Jeff Clune, for example, from OpenAI is now teaching at UBC. So really good people. And meanwhile, we don't have sort of a clustering, a place where these individuals can meet and mix with industry. And so when you create an institute of sorts, which we're working on, and now I've been fortunate to partner with the Digital Supercluster and have got some real traction on this. No firm announcements yet, and there's still funding questions to be determined for sure. But really on a good trajectory with all those stakeholders now, and universities and otherwise. And where I think this helps the mining industry is just finding those innovations that come out of universities. So for example, MineSense, Minerva has Alan Mackworth actually as the chair of the board, and much of the, my understanding, much of the technology has been sort of shepherded through UBC and the professors at the table there. So it's a real opportunity to bring things that are cutting edge and bring them into industry. And what you need, or what helps to do that, is a central location where you kind of bring tap this whole network, and you get people kind of connecting with one another and brainstorming ideas. And it's just a gathering place. Could be really it's something that generally BC and Vancouver are missing, and specifically I think mining. It sounds like with a mining center that Michael was alluding to earlier, the innovation, I guess, project that's being undertaken with the government. That's exactly a step in the right direction. And so seeing that in AI, is going to bring in more of these innovators into one central place.
Okay, great. And yeah, we do definitely have a center of excellence of mining and mineral exploration here in BC, and that innovation side is building quite strongly with a lot of momentum behind it. So I certainly see that growth of AI coming in as well. Some really interesting comments there on the talent side of things. I think that's one of the pieces that our industry, generally speaking, has struggled with. Not only on the innovation, technology, computer science side of things, but on a variety of fronts where we could pull in a lot of innovation from the social to the legal, environmental facets, all of those pieces. I think there's a lot of innovation to be had there. So I am just noticing the time. We're sitting at 2 to 3 minutes left. So I want to go to each of you. Jamil, I'm going to come to you last because I know you have some closing remarks for the group. So Steve, I'm going to go to you first and then over to Sean. I'm looking for your one quick takeaway from the session today, something that's really important for our audience to take away with them in sort of one sentence or maybe two. I'll give you two.
Yeah, no, I would really echoing the speakers. I mean, I think it's sharing of data and standards are the themes that come up again and again, and we've heard that other industries as well. I can give you the counterpoint that it comes up in a number of places, so mining wouldn't be alone in that. But if we can work with the government, just collaborate as an industry, there's so much to be done in those spaces.
Definitely. Sean, how about you? The one major takeaway from your perspective?
Yeah, it's those data standards, right? I mean, most machine learning projects that I see, it's 95% organizing data and 5% doing the machine learning part. And if we could flip that around, I think we'd make huge advances, because all the effort would be going into doing stuff with the data instead of trying to get the data into a format where anything's possible. So the more effort that goes in the front end, good databases, good organization, across the sector, will be in a much better place to really make rapid advances going forward. So that would be my takeaway message and closing comment. So thank you.
That's great. Thanks so much, Sean. And Jamil, final comment to you.
Great. I would say we are very innovative in BC. Look at the virtual room here and the companies that presented. We're individually very, very good at what we do. And I think for me, looking forward is to bring these innovations together. We've got a gift. I mean, we're so gifted in BC in the natural resources sector. Wouldn't want to lose our competitive advantage, right? My ambition is for us to really gain that and become the leader in the market. So, from my perspective, is to continue to drive that collaboration, and that's my key takeaway from today.
That's great. And I'm going to pass it back over to you for any final comments for the session.
Well, and thank you for moderating. It's almost like a speed date panel.
Speed moderating.
But thank you for keeping us on track. On behalf of KPMG and and ANBC, Steve and others that pulled the program together. Thank you to the audience as well as the speakers today. I think it was very enlightening for those of you who are hearing about these organizations for the first time, very enlightening and encouraging of the work that's currently underway. And Steve and team, we look forward to, I think we need to do a few more of these as the Mining Innovation Hub launches, and as we get more familiar with each other and the work that we do, and looking forward to conducting a few more of these as we move ahead here. So with that, Steve, do we want to close off? Any last comments from an AI and BC perspective?
No, I don't think really much to add. Just really appreciate everyone's time here. And again, I found this presentation really interesting. So let's keep the conversation going. As you say, Jamil, it'll be good next time. We'll do it again, part 2. And
please send your feedback through to EINBC, and hoping to improve and bring in your input as well into that. Okay, cheers.
Thanks all.
Have a good evening, everyone. Enjoy the sunshine.
Yeah, take care.
Take care. Bye.